Yay, another circuit to solve here, huh? Okay, we have this battery that's pushing out a current of 0.5 amps. So the current coming back here is also going to be 0.5 amps. So we have 0.5 amps running through the 9 ohms and the 10 ohms resistor, which means we're going to have a potential difference here of 0.5 times 10 ohms, right? V is IR, huh? So I times the R of 10 ohms. So we have a 5 volt potential difference across these 2 points here. But the EMF of the battery is 6 volts. And here we already have 5 volts, which means what remains between these 2 points here is only 1 volt, right? So we have a 1 volt across the 6 ohms. Now we are able to calculate the current passing through this 6 ohm because it has a PD of 1 volt and a resistance of 6 ohms. So let's call this I2, okay? So I2 can be calculated by taking 1 volt divided by 6 ohms. And it turns out to be 0.167 amps. So this current here is 0.167 amps, which means, haha, we now know what is I, because I have 0.5 amps here, which will split into these 2 branches. So 0.5 minus 0.167, which is 0.333. So that is the current here. So far so good. So what would this resistance be? We have already said that the PD between these 2 points is 1 volt. Huh? The PD between these 2 points, the PD between this resistor, and the PD between this resistor, that is all the same because the potential here is all the same. The potential here is all the same. So we have 1 volt across this resistor of R, and it has a current of 0.333. So to calculate this resistance is very easy. We know that V is IR. Huh? So if you have 1 volt across and the current is 0.333, what is your resistance? 3 ohms. Oh, solved. Okay, next circuit please.